All right, we're going to look at this idea of simple harmonic motion. It's called simple because it's a very basic sort of motion. It's just moving backwards and forwards between 2 points, but it is symmetric in its motion as well. What we know is that acceleration is always proportional to the displacement. So displacement from the center of the motion. So therefore it's going to be equal to some constant times the displacement. But it's important that that constant is a negative number in order for the motion to work. So rather than just saying k, we'll say minus n squared. That ensures it's a negative number. So why does it need to be negative? Well, if acceleration is proportional to displacement, so here I am at displacement 0. So acceleration is 0, it just means I'm moving with constant velocity. So let's assume I'm going that way. So here, but now I'm in positive displacement territory. Therefore, acceleration is now negative. I'm going to slow down because acceleration is in the opposite direction, which means eventually I must come to a stop. And now that acceleration will pull me back to 0. Once I go through 0, I'm now where displacement is negative, so acceleration becomes positive. So once again, I will slow down and eventually come to a stop. It just goes backwards and forwards and backwards and forwards like that. So basically, that's simple harmonic motion. Motion where acceleration is equal to some negative constant times the displacement. So if we have to prove it's simple harmonic, that's what we've got to prove. Let's create some equations. It is a differential equation. I'll make it v to v dx is minus n squared x. Separate out our variables. Now, I haven't got any initial conditions here, but what do I know about simple harmonic motion? I know that when it's out at its amplitude, it's going to stop. So I do know that link between displacement and velocity. So I'm calling it A for amplitude. So when displacement is A, velocity must be 0. I can now come up with an equation that will link v and x together. So if we integrate those, there's v squared. So v squared is n squared a squared minus x squared. So v would be plus or minus, because we're going backwards and forwards. So at any point, there's two possible velocities depending on whether we're going back or whether we're going forwards. Just like the one we saw yesterday like that, we can now have a look. V squared has to be greater than or equal to 0, of course. Well, n squared's a constant, but a squared minus x squared must be greater than or equal to 0. Well, the solution to that is x is in between minus a and a, so that's confirming, yes, we've got symmetric motion. We are going between minus a and a. Now, I want to find a displacement time equation. So I have to make a choice. Am I going to choose positive or am I going to choose negative? But remember, my initial condition was when velocity was equal to 0. So theoretically, I could choose either. How do I do it? The initial condition is I'm out at the amplitude. Whether it be the positive amplitude or the negative amplitude, I don't care. But if that's where I'm starting, I'm going to go with negative, because we're going to end up integrating an inverse trig function. I want it to mimic what the motion's actually doing. A cosine curve starts at the amplitude. That's why I'm going to choose negative. I'll end up getting inverse cos. If the question is starting at the center of motion, then I'm going to choose the positive, because that's what a sine curve does. It starts at the center of motion. It just makes the maths nicer. You can pick the other one if you want, but it just makes it nicer. Because see what happens? When I flip that upside down, the t dx is minus 1 on n root a squared minus x squared. There's our standard integral for inverse cos. So let's do that integration. And I get t equals 1 on n inverse cos x on a, sub in the x, sub in the a, and I have 1 on n inverse cos x on a. Let's make x the subject of all that. So nt is inverse cos x on a, and eventually we get down to x equals a cos nt. So I get a nice cosine function. So in general, acceleration is minus n squared x, we know that. Yes, there is this one, v squared equals n squared a squared minus x squared. I'd be wary of quoting that myself. Have a look at how many marks I guess. I just one mark, yeah, of course, quote it, you know. But that allows you to find the path of the particle. You will end up with x equals a cos, or maybe a sine, depending on what the question was and how you've integrated it, and a is the amplitude. Those you can quote. It's depends which end of the problem you're starting from. The particle has a period, well, it's a trig function, 2 pi on n. It also has a frequency. Frequency is the reciprocal of period. So period, that's the time it takes for one complete oscillation. So one complete back and forth. Whereas frequency is how many oscillations you have in whatever the time period is. Seconds, minutes, whatever. Let's look at one. So here we've started with the displacement equation. It says show that it's moving in simple harmonic motion. So I need to show that the acceleration is some negative constant times the displacement. It's just a matter of differentiating twice. So I differentiate 4 sine 3t, I end up with minus 36 sine 3t. Well, that is minus 9 times the displacement. It satisfies that rule that we know means it's moving in simple harmonic motion. So yes, that is true. And state the period. Well, the period will be 2 pi on 3. And so seconds, well, it hasn't actually said it's seconds, I've just assumed. There's usually seconds for these sort of things. Now, find the interval. You have trig equations. Don't waste time using calculus. Right? The interval the particle moves. Look at the displacement. It's a sine curve. That sine curve moves between minus 4 and 4. There's your path. Greatest speed. Look at the velocity. What's the biggest 12 cos 3t is going to be? 12. There's your greatest. Don't waste time using calculus. This time we're starting from the other end. They've given us acceleration is minus 4x and some initial conditions. Initially 3 centimeters to the right, and it's traveling with a velocity. So hang on, that means I'm not starting at the center of motion maybe? Because the center of motion would be 0, and we're starting 3 centimeters to the right of the origin. And it's got a velocity of 6, so I can't be starting out at the amplitude either. Let's investigate what happens here. Find the interval. Now, you want to quote minus n squared, that whatever that formula is, which I never remember because I never use it. Whereas I say, oh, no, it's just as easy to go, well, acceleration is v to v dx. So I'm just going to integrate, and I come up with that equation. It's not a difficult thing to do. But we know v squared has to be greater than or equal to 0, and so we know we're going between minus 3 root 2 and 3 root 2. Greatest acceleration? Well, we know the greatest acceleration must happen at the greatest displacement, because acceleration is proportional to displacement. We now know the path of the particle. Possibly I picked the wrong end, because I ended up with negative 12 root 2. Technically it's positive 12 would be the greatest, and that's what I'm going to write down. So the greatest acceleration is 12 root 2 centimeters per second squared. Here's an HSC one. Particle moves in a straight line. You'll notice, by the way, it's an extension 1. It used to be an extension 1, this stuff, but they've moved it into the extension 2 course and got rid of circular motion, which was far more fun. But anyway, 2012. So x is equal to this lovely expression. Prove that that is indeed simple harmonic motion. They've given you a hint. Show that it's in that form. So we're expecting some sort of shift happening. The centre's not at 0, basically. Well, 6 cos 2t plus 8 sine 2t, we can transform into one trig equation. I'll just draw my little triangle up there. I'm going to turn it into, which one have I chosen? I've chosen sine, haven't I? So the opposite is 6, the adjacent is 8, give me a hypotenuse of 10. The angle, well, I've got it in radians there, 0.6435. I'm just leaving it as alpha. I've defined alpha over there, so that's good enough. So we now know our equation is x equals 5 plus 10 sine 2t plus alpha. We need to prove it's simple harmonic motion, differentiate it twice, and I can rewrite that to become minus 4x minus 5. So yeah, you'll notice I said it's in the form minus n squared x. I didn't bother saying x minus c, because we know from graphing that just means it's a horizontal shift. It's still going backwards and forwards between 2 points. So when is the displacement 0 for the first time? Oh, well, it's just a matter of solving a trig equation now. Displacement is 0. We end up with sine is negative 1/2. From there we get the time is, and it's important we use radians, not degrees, because the time is that. 7 pi on 12 minus alpha on 2. If you use degrees, you'd be coming up with 7 times 180 divided by 2, and it's not times 180, it's 7 times 3.1415. So T ends up being 1.5108. Goodness knows what you would have got in degrees. Particles displacement is first 0, then after 1.5 seconds. We know that at the amplitude, velocity is 0, A is a maximum. So, back to your question. Your question was, can we just say acceleration is a maximum at the amplitude? Yes. That's a feature of simple harmonic motion. Once we've shown it's simple harmonic motion, yes, we can talk about all those features. And at the centre, that's where velocity will be a maximum and acceleration will be 0. Let's have a look at what they put in last year then. So we've moved it to the Extension 2 course. And what did they do? Did they make it harder because it was an Extension 2, or was it still pretty much the same sort of thing? So they gave us simple harmonic, they told us the period, they told us the centre of motion, they've also told us the maximum displacement. Find an equation for displacement. Okay, well I drew myself up a little diagram to get my head around what's happening here. Okay, so there's 0 on my number line, but the centre is actually root 3 to the right of that. There's the centre of the motion. Now they told me maximum displacement, not from 0, from the centre of the motion. So therefore it goes out to 3 root 3 and back to minus root 3. It starts at the amplitude, so I'm going to say it's a cosine function. I know it will take that form. It's going to be plus a constant because of the movement. All right, let's work all these things out. N ends up being 6. C is that distance there. That's the shift that we've got happening. Don't get confused, by the way, because remember it's x equals t. So whilst you're thinking, oh hang on, the shift with the x is normally in the cosine function, no, that would be the shift with time in this one. So our x is sort of acting like what we usually think y is, if you get what I mean. So the plus a constant is the shift in the x here. So c is root 3. 2 root 3 then is the amplitude. So there's my function. 2 root 3 cos 6t plus root 3. So, was that harder than what it used to be in Extension 1? No, not a heck of a lot. There was a bit more thought, I suppose, because of the movement of the centre and what have you. 6b, in that exercise you'll probably find they're starting with the trig and then go and prove it's simple harmonic motion, unless you're told it's already in simple harmonic motion. C is the one where it starts at the other end.